Good morning and welcome back to another episode of the Army's AI Integration Center podcast. I'm Lieutenant Colonel David Paddock, and once again, I'm your host for today's episode. I'm being joined today by Chief Vic Fernandez, who's coming to us from the AI Incubator. And today we're going to be talking about some of the risks and vulnerabilities of integrating AI into your organization. Vic, it's great to have you on the show today. Tell us a little bit about yourself, your background, and how you came to be here.
Sure. So good morning. As mentioned, I am Vic Fernandez. I am a cyber defense warrant officer. I'm also the information system security manager for LTC. Been in for almost 18 years. I've worked in air defense units and cyber units. Spent a lot of my personal time developing agents and other various things supporting cybersecurity.
It's great to have you here. So in our previous episodes, we've done a lot of discussion about what AI can do for unit organizations, how it can benefit them by improving the workflow, by expediting processes, by helping with things as simple as doing change of command inventories and doing part identification. Anytime that we're going to introduce this new technology, there's a trade-off involved there, right? There's going to be a risk that is introduced. Now, it may be a big risk or a small risk. Tell me a little bit about the risks that we're going to be introducing as we start to integrate AI into the Army.
The first thing I would start with is that, yes, AI as a topic has become way more popular than what it has been lately, but there's a lot of the same security considerations to think about when it comes to AI systems. AI products, whether it be an LLM or a fully functional agent or some type of agentic workflow, these things are not in a vacuum. You're not just going to be interacting with an AI system without any type of surrounding infrastructure. And that's where, in terms of risk mitigation strategies, that you can start. But let's say that a novice or someone who doesn't really know a lot about AI and they're concerned about what risks are involved, it's going to be what that AI system is telling them or what actions that they're allowing it to perform on their behalf. So for the most part, I think most security concerns are not new. They're the same ones that we've been dealing with for decades.
Well, and that's good because if they're familiar security concerns, we're going to have familiar security processes to mitigate some of those concerns. Can you walk me through some of the considerations that units should make when they integrate AI into their units and their workflows, specifically about how they are feeding in the data into those systems? How do units address that, and how do they manage the data while maintaining the quality to develop a useful data set of information that they can use to feed those AI agents?
I think this is definitely appreciated, but I think it really depends, because if an organization is in the business of generating their own data sets and or developing their own models, that's one umbrella of concerns. Separate to that is someone that's inheriting something that's already built and the risks associated with that. So if they're in the business of developing their own data sets and training their own models, if I was advising them, I would point them to the authorized data platforms that we have in the Army. There's a finite set of those. And that kind of eliminates a lot of concerns because of where it's housed, and that's getting after the underlying infrastructure where it is and the controls that are inherited when you dump data into those authorized platforms. And then as for just raw data, where you're getting it from, being able to explain the ancestry of that data, as well as the ancestry of a model or maybe its surrounding harness. That's kind of the bread and butter, because again, taking a step back, if you just remove AI and just replace the word AI with software, secure software supply chain is applicable in the situation. It's the exact same thing. You want to filter what's coming in and be able to prevent any type of disruption to the system by asking, hey, where did this come from? And what does it mean when it gets to its final destination?
When you talk about the approved databases that are being used, because as units start to adopt AI, there's an inherent risk that they're going to just grab an off-the-shelf system. They're going to start dumping information into some commercially available model. But there are both Army models and there are Army databases, and there's specific information controls as to what we can do with that data and where we can send it.
That's correct. Yeah. On that note, a organization should be asking what platforms exist already for consolidating data, for developing AI products, and for using AI products. So one example is for AITC, we have our in-house platform called Expedition Zero, where we deploy AI and ML applications onto. Some of these applications have connectivity to model providers such as OpenAI. All of that is authorized. All of that is above board. Those endpoints to OpenAI, those are all authorized. So if somebody wants to build something from scratch, so to say, I would just point them to the existing and authorized endpoints that we have already and advise them not to use the public offerings.
I think that's an important thing to consider because the approved developed systems that are already fielded out into the Army that are developed at places like AI2C or adopted formally, there's deliberate development that's gone into that with AI teams where we've addressed the security concerns, the data management, the pipelines, and without the consideration of data security and cybersecurity and all of the other aspects that went into validating that model for use in the Army, they're introducing system risk, potentially their own systems as well. Mm-hmm. One of the things that we've heard a lot about, and we've touched on it before, are concerns regarding hallucinations from these AI models. What can you tell me about hallucinations and the security concerns that they introduce?
I would say the security concerns are more on the human cognitive side, because when a model hallucinates, it's just working by design. It's making predictions based on the context that it has available. So if you don't want hallucinations, then you as the developer of an AI product has to bake in some type of grounding in the harness to prevent the model from trying hard to solve the problem that the user is asking for help with.
So thinking about it in that context, right, this is a system that's doing as it's been trained to do, is providing answers, it's trying to be helpful. It makes it that much more important to make sure that the questions that are being posed to the system or the problems that are being posed to the system are very deliberately framed, that we're leaving necessary outs for the system to say no. Is there anything that we can do as we start to field these systems that can improve our ability to do that? How do we approach that? And can you give me some examples of how we might format a question or a prompt into an AI agent that would support that negative output more effectively?
With the questions that you're asking, I keep thinking of it in two perspectives. One is the user, and the other one is a developer. So as a user, I think it's important to understand that the way an AI system is built is going to be different depending on where you go. So when you're interacting with an AI system, you want to understand the system prompt that went into this capability might be different from another AI system. And so if you're getting back a lot of positive feedback or a lot of affirmation, it might be baked into that AI system prompt to just be very overly collaborative. So as a user, you have to focus on what you put in your prompts. You have to bake in some type of guardrail or failure mode saying, hey, I need help with this, but if you're not able to, let me know and I'll provide additional context. Not just put the bare bones prompt in there. You have to go a little bit further and not be lazy with what you're putting into the system, because if you're lazy, then the system is going to give you an equal type response. And that's a good opportunity to talk about the cliche of, garbage in, garbage out. So having a well-designed prompt includes not only what you want, such as goals, but also expected behavior of that AI system.
Well, I feel like you really hinted at two different things there, right? One is what information is coming out of the system. Mm-hmm. And I think that comes down to a unit responsibility to have some mechanism to validate data provenance. But the other thing that you hinted at when you started talking about the prompt engineering aspect, it seems like there's going to be a leader responsibility to understand that system's, I'll say personality, for lack of a better word, and how it's going to respond to those, whether it's highly affirmational, whether it's confrontational, whether it's collaborative, right? They need to not only understand it, but then have a responsibility to inform their subordinates about what they should expect as well.
I would say not only leaders in an organization, but also personnel that are filling staff roles. It is probably more on them to make sure that they've done the due diligence to verify the information that's coming out of an AI system. Most recently attended a leading agentic AI course put on by Carnegie Mellon University. And one of the vignettes was about a unit in a tactical environment. and processing intelligence using a agentic workflow. And the question was, at what point would you tell the commander about insights that the AI system generated? And one of my peers attending the class shared with everyone his opinion based on 20 years of experience and said, hey, not only would I verify the information that's coming out, but I don't know if I would bother the commander, even if it was accurate, because there's a lot of things going on. It's not just putting an AI system that's highly capable in front of a commander. It has to be a team sport with using that system to make sure that it's functioning the way that you want it to.
I think that's really interesting, right? Just because it had a valid output doesn't mean it's something that's going to inform the commander, right? There's a lot of staff work that doesn't inform a deliberate commander's decision. It's a staff function related to the warfighting function. And it may not deliberately drive a decision, but it is going to enable the formation to maintain the initiative.
Yeah, something else that really resonated with me from that course was they had 3 bullet points, and they were: capability comes from what you allow, risk comes from what you expose, and control comes from what you enforce. And so in terms of capability, if you want it to be more valuable, or if you want the system to be less valuable for whatever reason, maybe because of cost, it's going to be based off of what you allow. Same thing with risk. If you are very concerned with what a AI system can do, but if you are in control of what it has access to, then you can buy down risk, you can mitigate risk by limiting what you expose the AI system to. And then with control, it's what you enforce. So not only is it in the human processes of like, hey, this AI system said something, what do we want to do about it? Well, you can decide to do nothing with it. Or in terms of technical controls, limiting what that AI system can reach out and change. You can make sure that you remain the human in the loop to prevent that system from going out and making changes that you never intended.
So I really think that concept is great. And I think that's a really great set of 3 points. Let's dive in a little bit deeper on that. Control comes from what you enforce, because the military as a culture, we like to control the decisions that are being made as much as possible. What technical controls, really specific to models and agents, should units expect to be able to influence at their level? And what are things that they just need to understand are baked into the recipe of whatever model they're using? Are there controls that units have where they can influence the behaviors and they can influence outputs, or are all of those purely baked into the models that they're using?
I wouldn't think in terms of just the models. I would focus more on the surrounding harness of the model. So for example, one of the systems that we're building in our portfolio is focused on compliance. And so it has access to a compliance system called EMAS, which is very important for cybersecurity community within the DoD Veterans Affairs. So we all use this system for compliance records. And a user might not know, unless I told them, that when they enter questions to the system, that agent is interacting with that compliance backend, that compliance database. And they might be concerned with what that agent is doing on their behalf. But when you really dig into the documentation of that AI system and that compliance database, you'll find out that in order to make changes to the underlying database that we do not own, we're interacting with a third-party system that's within the DoD ecosystem. But in order for you to access that API, there's a few technical and administrative things that have to happen. One, you have to have a system interface agreement. So there has to be some type of written documentation that's signed off by your authorizing official, which is normally some type of general officer. And then that has to be on file with the Defense Information Systems Agency. That document saying what you want to do through that API, what level of access that you're asking for, and that all leads to your API key. So with that API key, that represents your authentication and authorization. So by taking that API key and feeding it to our system saying, here's the key, and now I'm going to ask you to do all these things on my behalf, your level of control is represented by that key. So if you want to interact with the system and have as little risk as possible in the administrative process, make sure that you only ask for the minimal amount of permissions required to accomplish the task, not just give the system complete and total control of your compliance records. I think thinking of things in terms of access control, whether it be authentication, how you're authenticating with these APIs, or authorization, what type of permissions are you interacting with? And then more importantly, at least to me as a cyber defender, is auditing. So your audit trail. In the cybersecurity community, there's something that one of our mantras is prevention is ideal, but detection is a must, meaning all of your preventive controls are eventually going to fail. So you want to make sure that you are prioritizing detection and make sure that you have someone looking at the logs, because the faster that you can find something, the faster you can respond to it.
No, and I think that's really good. And I think when we talk about control, we oftentimes think about that local control, but framing control as something like that API key, right? That's your conduit to access the information or the database that you're looking at. And you can bake in limitations with that key. Talk to me a little bit more about that audit trail and how that comes into play for ensuring security, specifically with these AI agents that we're dealing with today.
So the audit trail is, or any type of audit trail, just basic logging. A lot of folks think that logging is important for observability, which it is, but it is equally important for security. And so the distinction in my mind, at least, is one half is you want to audit trail for performance of the AI system. Is it performing as intended? And then the other half is making sure that no one's trying to exploit or damage the system. So again, me as a cyber defender, I'm more interested in the security aspect and looking at the logs to make sure that there's no anomalies that are violating that AI system's cybersecurity policy, and making sure that no users are dumping in malicious queries to maybe disrupt someone else that's trying to use the system.
Tell me more about what a malicious query is and what sort of risk it could introduce into the security structure of a system.
So as a user with all the positive intentions, it's not going to necessarily be malicious to yourself. But let's say you're using the system and I'm a bad guy and I'm trying to enter malicious queries. I'm doing that to either get information about the system itself. I'm trying to gain access to the data that maybe you have or interacting with. It's going to be someone else who has malicious intent that is entering queries to gain additional data. There's one framework that I want to bring up called MITRE Atlas. So I'll start with MITRE ATT&CK, and then I'll describe what MITRE Atlas is. So MITRE ATT&CK is a framework that's developed by MITRE. And what it's designed to do is to describe a cyber attack lifecycle from beginning to end. So to overly simplify it, let's say the first thing is scanning, and then you identify what's running on the system, you identify what versions of software, and then you exploit those things. So the entire attack lifecycle going from left to right or beginning to end, that's MITRE ATT&CK. You take the same idea, but you apply it to an AI system, and there's MITRE Atlas. You might have, at the beginning of the attack lifecycle, you might have conversations about data poisoning and baking in malicious data points that are maybe embedded within the model that attackers know are there and that they use to their advantage. Or you might go further into the attack lifecycle and do some type of malicious prompting. So that's MITRE Atlas in a nutshell.
So it's essentially looking inside of the system, and to use your phrasing, right, looking at that harness and all the different things that are supporting that agent, and it's looking for something that it can exploit to use later. Is that a good way to kind of summarize it?
Yes. Yeah.
Okay. So you've mentioned this supporting harness for the AI agents a few times. That's not something we've really discussed before. Now, when I think of an AI system, right, I'm going to imagine a black box, right? I put a query in, something happens, and then something comes out on the backside that's a response to the query. But it's a lot more complicated than that. And I like your harness concept, because really I've got this agent that is doing things, but there's all of the other things that are informing how that agent is going to respond to a query. Talk to me a little bit more about the different elements of that harness that let that agent work successfully and securely.
So the different components that go into a harness are going to be the memory, which is probably one of the most important things, the tools it has access to, and the environment, which is essentially the input and output of the agent. And then you have the model itself, whatever algorithm that's baked into it, and then the data set that it was trained on. So with memory, you're going to have short-term memory and long-term memory. Short-term memory being like your context window, token management, all that stuff. But for those who are not familiar with long-term memory, you have episodic memory, semantic memory, and then procedural memory. All of those you could just say as separate databases that have separate purposes. That's important in terms of security because what your agent is doing is going to be based off of what it remembers, and whatever it remembers is going to be based off of what's in those databases. So going back to the other cliche of garbage in, garbage out, whatever procedures that you bake into that procedural database or whatever facts that you put into its semantic database, that's all going to influence how that agent performs and its behavior. So that's something to consider not only when developing it, but also when using it. And same thing with tools and the environment, it's going to be input and output. So if you have a truly autonomous agent where it's acting on its own without much direction, you're not dealing with an agentic workflow, you're dealing with something that's operating on its own. What's really important to think about is the agent's own output becomes its input. And so understanding how that harness allows that to happen, that's going to be a key security consideration.
And I think that memory concept is a good way to envision it. The other thing that you mentioned was the training data set, but that's kind of a one-time thing, right? We're not constantly, people talk about training their agents. Most of the time, they're not really training an agent, though. They're providing RAGs documents in order to provide additional context, but training is typically a one-time affair that informs how that model understands and how it generates that neural network. Or am I misunderstanding that?
I would say that training is, you can look at it from two perspectives. It really depends on what side of the agent I'm talking about. So with the model itself, yes, you are training it and it could be a one-time deal, but I would offer that even those types of models are routinely revisited and retrained with additional data, maybe to do better predictions. But for the other side of the agent, you are kind of retraining it when you say, hey, you did a great job with that task. I want you to keep doing it that way. It's going to save that as not only content in its context window, but it's going to save that in its episodic database, if you will. So it's going to remember, hey, Vic was really happy that I completed this task in this way. Therefore, I'm going to use that. What you're doing is you're training in context. You're not completely retraining the model. You're just giving it additional data points within its harness that it's referencing from that point forward.
Well, I think that's really interesting because it helps explain why a single agent may give different responses to different users, right? If I have two different people working on a single LLM that's the same model on the same version, the longer that they use it, the more likely it is that they're going to get responses that are slightly different because they liked it, or maybe something as simple as they directly responded to it, or they incorporated that into a product that they're developing. That agent understands that. So there's a reward mechanism in that short-term episodic memory that is continually retrained back into the system. Going back to the security side. So you mentioned the tools that it can access, and we had touched on that earlier when you talked about the API keys that are going to control how it accesses it. Talk to me about the different tools that it can access and which of those that we can control with keys and which of those are things that are outside of our control that need to be considered in the security context.
When you think of anything in a security context, whether it be digital or human, you can boil it down to a subject and an object. So in this situation, with dealing with AI systems, the subject is going to be the AI system, and then the object is going to be whatever you're trying to interact with. And so access control is kind of king in this situation where you got to think about your authentication, you got to think about your authorization, and then obviously you got to make sure that some type of audit log is in place. So an API key is just one method of providing authentication and authorization. Something else might be certificates. So we have certificates on our smart cards. That's the exact same concept as an API key, where you are authenticating, and then based off of whatever authorization that was granted to your certificates, it's the same principle of API keys. Or in a much less secure environment, you might have username and password. In terms of controlling what the agent is doing or what the AI system is doing, you might not want to allow it to interact with systems that only require username and password. That's not the greatest security option that you can use. Now, something else I want to talk about is the different access control schemes that you can put in place. So what's very popular, not only in the DoD, but just anyone using any type of IT system, is role-based access control. So I kind of touched on it a little bit with when I was talking about the API keys, but when you're interacting with some other external third-party system, you should consider what roles are required for that task. And so if you want to allow work to happen, you should ask or coordinate about what roles do we have that represent the different tasks we can accomplish. And then once you boil it down to the least capable role, that's what you use with the agent. So by default, you should be trying to promote least privilege to not introduce additional risk.
Introduce everything at the least access, additional access as required, as opposed to granting maximum access at the entry. When we talk about access control for external tools at the unit and organizational level, is that something that they need to directly consider? Or is that something that the Army is implementing on a more broad application that units are going to have certain tool sets that they can access based off of their organizational hierarchy or their doctrinal mission?
So in terms of process or where to look, where to ask for access to some type of data repository, I would start with the Army Data Operations Center, the ADOC. I can't tell you today exactly what systems that it's currently managing access to, but I know that that capability will become the main touch point, the 911 to call essentially when you want access to certain type of a data set. I think units should get the habit of asking, maybe not so much at a technical level, but just as an idea about MCP servers. MCP servers are a great way of consolidating tools into one capability. So instead of everyone grabbing the different tools that they want or need, you could just ask like, hey, is there a MCP server available that we can all interact with the same interface? So MCP being Model Context Protocol, it is just a protocol. You can develop your own, or you can ask around for an existing one. I advocate for MCP servers because as a cyber defender, it makes it easy to implement that authentication, authorization, and audit log. As opposed to relying on all these systems with different types of APIs, you can consolidate access to that with one MCP server that anyone can interact with.
It's great to know that there are tools that are out there that make it easier and more streamlined to access the information and the data that units need while maintaining that security infrastructure. I think we hit a lot of great topics today, and I think we did a great deep dive into a lot of the security concerns and the structures that are in place and should be in place, ranging from the technical applications and how we're controlling data access all the way to the unit level and how leaders are involved with their soldiers and the cognitive responsibilities of the users.
I do just want to reiterate that what we talked about in the beginning is that AI security is not that much different from the other pre-existing cybersecurity principles. And to me, again, one of the most important ones is the prevention is ideal, but detection is a must. The faster you can identify there's a problem, the faster you can jump in and address that risk.
Well, I think that's a good note to end the episode on. Chief, thank you for being here today. You're bringing obviously a great depth of technical expertise in the field of both security and artificial intelligence. Appreciate you coming and being on the show today. I think this is a great conversation. It's really going to leave organizations with some important topics to consider as they implement AI into their unit workflows.